In this video, we are looking at solving one-step linear equations, and we are using the balance method, and it must be used at all times. So the thing with equations is you can get pronumerals, which are the letters, and numbers on both sides of the equal sign, okay? So both sides of the equation. And what you need to do is look at collecting like terms and adding or subtracting them. So like terms are the numbers, are like terms in this case, and sometimes you get pronumerals on the other side or within the equation itself. So we're going to start with some really simple one-step equations, and the key aspect of this is remembering that letters are on the left and numbers are on the right. So we want our letters to be on the left-hand side of the equal sign and our numbers on the right-hand side. So basically what we're looking for here is to solve the value of the pronumeral. That's why that the letters, the pronumerals, must be on the left-hand side of this equal sign and numbers on the right-hand side. So we have a steps key here. Black is the question, green is my first move, and blue is my second move where I will answer this. So the focus is to remember that letters must be on the left-hand side of this equal sign and numbers on the right. So when we have this a plus 1 equals 4, I can see my letter is already on the left, and I'm happy about that. What I don't like is this plus 1, this positive 1. Okay, this needs to go. So what you need to understand is that any symbol, such as addition and subtraction in this case, sitting with a number or a pronumeral is owned by that. That means that's a positive 1. Okay, so I'm going to start with this 1 because the plus 1 and the 4 are like terms, so I'm going to use those. So I start here and say, what is the opposite of positive 1? It's negative 1. And what I do to one side, I must do to the other. Okay? So you must do exactly the same thing on the other side. You're balancing it out. Now we know that 1 minus 1 is 0. Okay? So it cancels that out. I drop the a down, put the equal sign, try and keep it lined up, and go 4 minus 1 equals 3. Now, this I've discovered a equals 3. If I substitute a back into this, it would be 3 plus 1 equals 4. Working backwards shows me that I have that question correct. Let's look at number 2 here. Okay, p plus 2 equals 6. Letters on the left, numbers on the right of the equal sign. I can see the letter is where I want it to be. The plus 2 shouldn't be there because I don't want numbers on this side. I want numbers on this side. So I'm going to start here. The opposite of positive or plus 2 is negative 2. What I do to one side, I must do to the other. 2 minus 2 equals 0, so it cancels itself out. I drop the p down, the equal sign, and I solve 6 minus 2 equals 4. Now if I backtrack and I put the substitution in and put 4 over here instead of p, 4 plus 2 equals 6. That is correct. b plus 5 equals 12. We want letters on the left, numbers on the right. So what I do to one side, I must do to the other. So b is where I want it to be. This plus 5, this positive 5 doesn't need to be here. I need to get rid of it. So whatever you need to get rid of, you tend to want to start with, okay? And you must work with like terms, so numbers and numbers here. So the opposite of plus 5 is negative 5, and what I do to one side, I must do to the other. So this cancels out into nothing because 5 minus 5 equals 0, okay? So 5 minus 5 equals 0. And then I drop the b down, the equal sign, and I solve this here. 12 minus 5 equals 7. Let's now take a look at subtraction. We're going to do exactly the same thing in subtraction that we did in addition. However, instead of it being a plus symbol, it's a subtraction symbol. Now remember that this owns the subtraction symbol, which makes it a negative 4. Okay, so when we do this, we remember we collect that symbol in front, always for algebra. Okay, so let's take a look at this now. Letters on the left, numbers on the right. I like where the b is. I don't like this negative 4. Opposite of negative 4 is plus 4, and what you do to one side, you must do to the other. We know that negative 4 plus 4 cancels out into 0. Okay, we drop the b equals, and we solve this. 7 plus 4 equals 11. If I substitute the value of b, which is 11, into this equation, okay, it will be 11 minus 4 equals 7, and that works. Okay, let's try the next one here. So we've got 9 minus t equals 3. We've just got this switched around the other way now. It doesn't really matter. We've just got to pretend that we can't see it, but that's actually a positive 9. I want letters on the left, numbers on the right, so the t is going to stay here, but the 9 has to go. So the opposite of positive 9 is negative 9. And what I do to one side, I must do to the other. Okay? So positive 9 minus 9 cancels out into 0. And we have to drop down the t equals, and we solve this. 3 minus 9 equals negative 6. So the value of t is negative 6. So if we substitute that back in, we will have 9, okay, minus 6 equals 3. And the last one we have here is c minus 11 equals 15. So again, we want letters on the left, numbers on the right of the equal sign. Letters here correct. This number doesn't belong here, so we're going to start with this one first. Opposite of negative 11 is positive 11. What I do to one side, I must do to the other. And of course, this cancels out into 0 because negative 11 plus 11 is 0. I drop the c down and I solve this here. 15 plus 11 is 26. If I pop the 26 in replacement of the c, it would be 26 minus 11 equals 15.